Hi guys, it's going to be a lecture video for Motion in Two-Dimension chapter, and we're going to have three sections: free fall, vector, and motion in 2D. Alright, let's get started. What is free fall? We actually had two scientists a long time ago, and Aristotle said heavier objects basically fall faster. Later on, another scientist, Italian physicist and mathematician came in, and then he said, nope, it doesn't really depend on how heavy the object is. It actually depends on one thing. It depends on gravity. So, and Galileo said the reason that objects actually fall at different rates in regular life is air resistance, because air resistance basically resists objects' movement, and that air resistance affects different shaped objects differently. So that's why every object doesn't really fall at the same rate on Earth due to the air resistance. So, according to Galileo, everything would basically fall at the same rate. So regardless of their mass, an elephant and ant would fall the ground at the same time if they were dropped from the same location. All right, so what is gravitational acceleration? So it's basically the near the surface of Earth, all objects experience approximately the same acceleration. So remember, acceleration is change in velocity. So that means once you drop an object, it is going to speed up, and that speed up rate is actually equal to a certain number, and that certain number is 9.8 on Earth. And of course, that's an average, depending on your location. It might vary a little bit, but it's just going to be 9.8 in average. So once you drop an object, it's just going to speed up by 9.8 meters every second. And it doesn't matter what the mass of the object is, everything will basically speed up at the same rate. And in some questions, to make the calculation easier, you can also use that as 10. But for on-ramps, you cannot use it as 10. It's always 9.8. And acceleration due to gravity is basically known as gravitational acceleration, and it's shown by lowercase g. And that will depend on how far away you're from the center of the Earth. So that's why in the equator, you're going to be basically farther away. So that means you're going to have less pull of the Earth. So that means you're going to have less gravity, but near the pole, north and south poles, then you're going to have basically closer distance to the center, then you're going to basically have greater acceleration. All right, what's free fall? So free fall is any motion of a body where gravity is the only force acting upon it. So that's the definition of free fall. So in that case, if you drop the object, or if you throw the object down or up, all of those will be considered as free fall, because after they leave, because we are talking about the motion when it leaves your hand, all of them will actually have the same amount of force, and that's gravity acting on all of them, and that's the only force. That's why they're all going to be considered as doing a free fall. And of course, we're going to have some math related with those. So if you drop an object from rest, obviously the initial speed will be equal to 0, and the displacement will be negative h, because we are basically starting from this location and then we are moving downwards. So since we are moving downward, then the displacement will be negative, and velocity will increase by 10 or 9 meters per second, 9.8 meters per second. And the acceleration of this object is going to be negative 10 or negative 9.8. And the height it is released can be found with the following equation. So this height is equal to basically 5t squared. So your height will depend on one variable only, which is time. And this is not going to be a surprise for us, because delta x, we are going to be using those four kinematics equations in the motion in two-dimension as well. So remember, they are delta x is equal to v initial t plus 1/2 a t squared v final equals v initial plus at, and then v final square equals v initial square plus 2a delta x. And the last one is delta x is equal to t over 2 v final plus v initial. So we are still using those four equations. So for this case, it says initial velocity is 0. So initial velocity is 0. So delta x, which is my height, so height is equal to basically 1/2 a t squared. So my a is g, so it's going to be 1/2 gt squared. All right, so that's how we find the height of this guy. And the graphs of this guy is going to look like this. Since you are basically starting from above 0 location, you're going to be over here. And since you're accelerating and you keep accelerating, so you are basically starting to increase your height more and more, and it's going to infinity. So basically it's an increasing velocity. So your velocity is going to increase. However, so you're going to start from 0, but it's going to basically increase with the same amount, same rate, which is 9.8, but it's going to be basically moving down, so because it's going in the negative direction. And your acceleration is just going to be negative g. And if you throw an object down, then what's going to happen? Initial speed is going to be greater than 0. Your displacement is still negative h, and you're going to still increase with 10 meters per second or 9.8. And your gravity is still going to be negative 10. And there's no special equation for this. And the graphs are going to look very similar, except you are actually going to change your speed or your displacement a little bit steeper in that case, because you're going to have initial speed. So that means you're not going to start from 0. You're not at rest. You are basically above 0. But you are still moving downward, so you're still going in the negative direction. But it doesn't matter what type of motion you have, you're still under the effect of gravity, so that means your acceleration is still negative g. And if you throw an object upward, then what's going to happen? So initial speed is going to be greater than 0, and it's going to be positive this time because you are basically throwing the object upward. And as it goes up, it's going to lose its speed by 10. And when it's going down, it's going to increase its speed by 10. And the velocity increases, and the displacement is going to be 0. Why is that so? Because you're starting at this location and you're ending up at the same location. So there is no displacement overall. And there's only one critical thing. At the highest point, you basically you start with some speed. You slow down, slow down, slow down, and then you reach to 0. And that is basically the highest point that you can reach. After that, you just basically fall down. And initial velocity that you had over here is equal to your final velocity. The only difference, one goes up, the other goes down. So that means one is positive, the other is just negative. And time to go up and time to go down is equal. And this is also another point. So what does that mean? So I am talking about this location, for example. So my velocity at this point is going to be equal to the velocity at this point. The only difference, one is positive, the other is negative. And it doesn't matter which height we are talking about. At all heights, the velocity up is equal to velocity down. And my graphs for this is going to be a little bit different. So you're going to start from ground. So you're going to actually increase, and you're going to change your height in a positive direction. But as you go up, you are going to actually slow down, slow down, slow down, and then you're going to stop at this location, and then you start to actually move down in that direction. So, however, your velocity is not going to have any different shapes. It's just going to be a straight line, because the rate of change in the velocity is always the same. It's changing by 10 or 9.8 meters per second square all the time. So when the time is half, it's just basically going to reach to 0 velocity. And whatever the initial velocity is, it's going to reach to the final velocity, the same number. It's just negative. And your acceleration is still negative g, because the only force acting on the object is gravity. Or if you throw an object from a cliff. So what's going to happen in that case? You still have initial velocity as more like greater than 0. As you go up, your velocity is going to decrease by same rate, and you still reach to 0 speed when you are basically all the way up. And when you're going down, you're going to decrease your velocity by 10. Your acceleration is still g. And your displacement this time, you start at this location and you end up right here. So your displacement is basically that much. But since you are displacing down, it's going to be negative h. And final velocity will be more than your initial velocity, because at this point you have the same speed. V up, V down, they're equal. However, you are basically going beyond this point, so you're speeding up more. So they're going to have more final velocity than initial velocity. And here V up equals V down. When is this correct? When they are at the same elevation. And basically these are what we have for object thrown up. And my graphs for this, so you're going to start from above 0 this time, and then you're going to slow down, stop, and then you start to fall down back. And you initially start with some speed. You're still having straight line, but you're basically going to reach the 0 velocity earlier this time, and then you're going to have more time to fall, and then that means you're going to have greater final velocity than initial velocity. But again, one thing is not changing. Your acceleration is still negative g. All right, vectors. You're not going to have any question probably about directly vectors, but the idea of vectors is important. So we are basically cover the vectors as well. All right, what is a vector? So vector is basically this arrow shape that you guys see. And what makes it a vector? This tail or the head, and this basically bottom part. So the tip and tail, or the head, anything that has that. Actually, this is not tail. Tail is going to be the bottom. So the head is basically going to show the direction of the vector, and the tip or the tail is going to show you where you start from. And all vectors has tail and head. Length of the vector. Vectors are going to have an important characteristics. The length will matter. So this vector and this vector, they're not going to represent the same thing. The length will determine how great it is. So the magnitude, the numerical value will depend on the length of it. And all vectors will have directions, and we can add, multiply, divide, or subtract the vectors. And anything that has a vector quantity, then they're going to have those properties. So force is a vector quantity, so 10 newtons of force means basically, or the representation of this with absolute sign is going to tell you the magnitude of the vector. And this one on the head is going to tell you this is a vector quantity. Alright, so these are basically the properties of the vectors. And how do we do the operations on vectors? You can basically move vectors from one side to another, but the only thing that you should or can do is basically move the vector as it is. You cannot actually change its direction. You cannot change the length of it. So I can take it from there to here. But I need to be careful about the direction and length of it. So if I just bring it right here, then it is not being the same vector because I have changed the direction of it. So adding the vectors is basically tip to tail. So if I had, for example, this and this, A and B, if I have A and B together, and if you want to add the vectors, you basically, doesn't matter which one you add to which one, but you basically go tip to tail. So tip and tail, basically they're going to go together. All right. And subtracting vector is the same thing, except you basically change the switch the direction. So if this is B, this is negative B. And subtraction is basically adding with a negative vector. Multiplying is basically extending the length of the vector by the integer that we are basically multiplying it or dividing. So if you're dividing it, that means you are basically having a shorter vector. And resultant vector is basically the sum of more than two vectors, two or more, and it is basically shown from the starting point to the end point. All right, so that is the resultant vector. So this is A, this is B, and if you want to have A minus B, we basically flip the B 180 degrees. And again, we are starting from here and adding this A vector with the B vector. But my resultant vector is going to be basically drawn from the first point to the last point. And that C is the resultant vector. And we have a couple of vectors over here. So A is A plus C. So A is basically 2 units right, 2 units up. C is 2 units up. So if you would like to add A and C, so what do you need to do? It doesn't matter where you start from. You just need to know that you are basically having the same direction and length. And you add tip to tail. So since this is your C and this is your A, this is basically the combination of it. What is the resultant vector in that case? Your resultant vector is going to be from beginning to the end. So once you combine those 2 points, that's basically your resultant vector. And if you would like to draw it for all of them, you basically add the vectors. It doesn't matter which order. So you basically draw the vectors as they are given and then add them tip to tail all the time. All right, so this is the key thing. So tip to tail. So as you can see, this is tip to tail, tip to tail, tip to tail, tip to tail, and all of the resultant vectors are basically drawn from the beginning to the end, beginning to the end, beginning to the end, beginning to the end. All right, so that's how we draw the resultant vectors. And resolving vectors into components, that's basically very important for forces and motion most of the time, or any time that you're using a vector with an angle, you need to be able to figure this out. So a vector is going to be, vector with an angle is going to be sketched like this, but you can have the projections on the x and the y-axis. And the projection on the axis is going to be known as ax, or x component of the a vector, or the one on the y-axis is going to be the y component of a vector. So, and there is a way for us to find those ax and ay in terms of a. So in this case, we're going to use trigonometric functions. So if we are basically looking for, if this is the vector A, and if I'm looking for, and this is the angle that I know, and if I'm looking for the adjacent side of the angle, then I basically use the cosine. And remember, cosine is adjacent over hypotenuse, right? Is it? Yes. So that's why once you multiply A, which is this guy, with cosine of the angle, what is the cosine of this angle? Adjacent, which is AX divided by A. So this is the cosine of the angle. And once you multiply with this A as you can see, you are basically finding AX. Same idea, AY, but AY is the opposite side. So AY is right here, but this vector can be basically moved to this side, and then you basically have a triangle right here. All right, so that's how we find AX and AY. And of course, since we have a triangle right here, then we are going to be able to use Pythagorean theorem. AX squared plus AY squared is equal to A squared. And the angle itself is going to be arctangent of AY over AX, because tangent itself is equal to opposite over adjacent. So that's why AY is in the opposite side, AX is in the adjacent side, and the inverse function of that tangent is going to give you the theta. And we have special triangles. So 3, 4, 5 special triangle is going to have the angles of 37, 53, and 90 degree. Or if you have 30, 60, 90 degree, then across 30 you're going to have X distance, across 90 you're going to have 2 times of it. And across 60 you're going to have square root 3 times of what you have across 30. And if you have an isosceles right triangle, X and X, and your hypotenuse is going to be root 2 times of what you have on the sides. All right, projectile motion is basically the combination of free fall and motion with a constant speed. So we basically have horizontal projectile motion, and this horizontal projectile motion is free fall. So you drop an object, it's free falling, and it's going faster and faster, but it is going to have horizontal speed. So it is also going to move in the horizontal axis. And motion in the x and y axes are independent from one another. So whatever is happening on x is going to stay on x, and whatever is happening on y is going to stay on y. So we're going to basically use the 4 equations in both of the axes. And what do we have? What type of motion we have in the x-axis? As you can see, it is basically traveling the same distance every time. So it is a constant velocity motion. And on the y-axis, we have uniform accelerating, because it's basically speeding up with 9.8 meters per second every second. So, and important thing, object dropped from rest. So this behavior is going to be the behavior of object dropped from rest. And the combination of those two motions is going to be the projectile motion, or horizontal projectile motion. And it's basically going to look like this. So you are basically going to have your Vx. Vx, it is going to be the same vector, 2 units vector every time, because it's constant. There is no force acting on the object on the x-axis, but there is a force acting on the object on the y-axis. So that's why it's going to speed up every second on the y-axis. So as you can see, it's increasing by 1 unit every second, but your motion on the x stays the same. So in that case, your acceleration on the x-axis is 0, your Vx is constant, and your Vx, anytime, it doesn't matter what time, it's equal to the initial velocity that you had. And Vx initial is equal to initial velocity, kind of same thing. And we can find the range from here. So range is basically how far it goes in the x-axis. And a way for us to find it, since there's no acceleration, then it's just going to be v initial times t. And since my v initial is the same throughout, then we can just say vx times t. And what we have on the y-axis, on the y, gravity is my acceleration, and my velocity is increasing by gravitational acceleration every second. And my Vy at any second will be just given by t times g, and my initial velocity on the y-axis is just 0. So initially on the y-axis you start with 0. There's no movement, there's no y vector, there's only x vector in here. So you basically speed up, you start to create your v vector on the y-axis later on. So you start with 0 meters per second initially on the y-axis, and your height is going to be basically 1/2 gt squared. And what are the properties that we have in this projectile horizontal motion? V of the object is a vector sum of x and y components of it. So V of the object on a projectile motion is not Vx or Vy. It is this pink one, because V is always the combination of the motions of both. So to be able to find your V, you basically use the Pythagorean theorem, and you basically take the squares of both of the components, add them together, and to take the square root of them to find your original V. And A is also the combination of both, but since you don't have any acceleration on the x, then your acceleration is going to be your acceleration on the y-axis, which is g. All right, so that's what we have for horizontal projectile motion. And what are the graphs of this guy? So on the x-axis, we are basically moving with the same rate. We travel the same distance all the time, so that means my velocity is constant, and that means my acceleration is 0. So I don't have any acceleration on the x-axis. But on the y-axis, it's basically the exact same thing that we have on free-falling object. It is going to go down more and more, and your velocity is going in a negative direction because you're moving in a negative direction. And it's increasing with the same rate, and your acceleration is still negative g. And projectile motion with an angle. So it's basically free fall with a horizontal and vertical velocity. In the previous one, we only had Vx, but now we also have Vy. So once you have Vx and Vy, what's going to happen? So at the highest point, you basically have y component. So this Vy is basically speeding up, slowing down, slowing down, slowing down, and it reaches to 0. And then it starts to speed up in the negative direction. But at the highest point, your Vy is equal to 0. But this is not the velocity of the object. It is the y component of the velocity of the object. But what do I have? I have also Vx at all times. So that means my Vx, since there is no force acting on the x-axis, Vx is staying the same. There is no change in Vx. But at the top point, this guy reaches to 0, so only thing that I have is the Vx. So at this point, so you see this pink velocity vector? It becomes Vx itself. So at the highest point, your Vx is going to be basically the V of the object. But other than that, it's always your V, this pink vector is always greater than the components of it, because it's basically the hypotenuse. All right, so on the x-axis, your acceleration is 0 because there's no movement. There's no force on the x-axis. Still constant. Initial speed is equal to the Vx, or Vx at any point is equal to whatever you had in the initially. And you can find the range by multiplying the Vx, x component of the velocity, with the time. And on the y-axis, your gravity is your acceleration, and Vy, what do I mean by here? Vy changes. All right, so your Vy is changing by g, basically. It doesn't matter if you go up or down, you are changing your speed by 9.8. And initially, your initial velocity is going to be half of the entire time times g. And your delta y is 0 because you start from one point and then you end up at the same height again, so there's no displacement on the y-axis. And your y initial is equal to negative y final, so this guy right here, initial y, is equal to final y. The only difference is they are in the opposite directions. And anything goes up and down, they're also equal, and I think it's more clear in this vector diagram. So this is 3 units. At the same elevation, it is 3 units. But one goes up, the other goes down. This is 2 units up, this is 2 units down. So one goes up, one goes down. So anytime that you're going up and down at the same elevation, you're going to have the same speed. And at the highest point, h max, you're going to have 0 velocity. And your h max, time for you to reach to the highest point, is going to be half of the total time square times g over 2, which is 1/2 gt squared. But your t, in this case, is going to be the half of the entire time. Because for you to go up and down is going to be the same time. And we know that going up from 0, from this location to this location, is basically 1/2 gt squared. All right, so since we are talking about h max, it is basically going to happen at the halfway, so we are taking the half of the time in that case. And a way for us to find the x component of the velocity is initial velocity times cosine of the angle, and y component will be the sine of it, and the angle theta is arctangent of vy over vx. T up equals t down. And what are the properties? Motion in the x-axis is still constant, and motion in the y-axis is the exact same thing as object thrown upward. And velocity of the object in minimum at h max, but it's not 0. So here, my velocity at this point is the minimum, which is vx, but it's not equal to 0. And as the angle increases, t increases, and its maximum when the angle is 90. So this guy is going to take longer and longer time as it goes higher and higher. So as angle increases more and more, it's going to take more time to travel, but it's going to reach to its maximum when it's 90 degree. When you pass 90 degrees, it's basically going in the opposite direction, but it's still going lower distance in terms of height. And third, there are 3 different velocities: velocity in the x-axis, velocity on the y-axis, and the velocity, the actual velocity. And actual velocity is the vector addition of vx and vy all the time. And when we are talking about the graphs, we are basically talking about the same graph for this case as well. So your motion on the x-axis is a constant motion, so you basically travel the same amount on the x-axis all the time, which gives you a constant velocity and gives you 0 acceleration. And on the y-axis, this time, since we go up and down, we are going to slow down first and then change the direction and speed up as we go down. And our velocity basically starts from some certain speed, decreases to 0, and then changes its direction and starts to speed up. And your acceleration is constant throughout. And you can also have different cases, so you can start throwing an object from above the ground level and then go down below, or you start from the ground level and throw out something above ground level. So in those cases, nothing's actually going to change except your height. We are still using all of the kinematics equation, the forward kinematics equation. The only thing that is changing in those scenarios is the height. Other than that, everything else is the same way that we actually do for projectile motion. your acceleration is still gravity. At the highest point in both of them, your velocity is still 0. When you're going up and going down velocities, they're still the same. Your motion on the x is still constant for both of the cases. And we use kinematics equation to make calculation, but we use them separately for both x-axes, for both x-axis and y-axis variables. All right, so basically that is it for motion in 2 dimension. And of course, this is a really quick review, and there's no question in this part. To be able to comprehend this better, I advise you guys to watch the question solution part, which I will be posting next week. So this week you have them as an homework assignment. So next week I will be posting the solutions. So please, please, please go ahead and review those solutions because you're going to need them in the final test. All right, thank you for watching. See you in the next videos.